please go by the attendance office as soon as you can. Again, instructors second period, please go by and sign your attendance reports for the 6 weeks. If you have not done so, thank you. Olivares to the front office. Sabrina Olivares, you need to come by the front office. And then Costa to the front office. Miranda Costa, you need to come by the front office.
How do you know? How do you know he loves Avella? Yeah, he loves Avella. That's what I think. I'm gonna cry. Why are you gonna cry? That was my best friend. R.I.P. to Side. Where he moved? Avella, I think he moved.
Wow, okay. Story.
And he doesn't have his phone, so. Oh my gosh, dude. He's like, can you tweet on again? What were you gonna say?
What time are
That was a close one.
Alright. Hey guys, what's up? So let's talk about these things. Your calculator, the notes, and the assignment. If you don't have one of these things, just come up and grab it. You'll be decided something. Alright guys, you're gonna have to take a seat. Let's get set down here. Let's get started. Alright.
Doors closing on your future, Melissa. Melissa, you don't work for the Secret Service, Melissa. Take off the headphones, Melissa. Okay. All right. Yeah.
Today we're talking about measurements. We're gonna get into like sig figs and everything, okay? So everyone look at the notes from the top. Accuracy. Okay. Accuracy is talking about how close a measurement comes to the correct or accepted value. Alright? Precision refers to the closeness of the values for set measurements. That's how close they are together. Okay, so find an empty space in your notes somewhere. Like we're gonna write something about precision and accuracy. Okay, so just find a blank space somewhere. So at the top of this blank space, we're going to write accuracy and precision. Accuracy versus precision, actually. We're going to compare the two.
The bottom, like, blue space?
So if you have some blank space, you can put it maybe there, a little space there, on a separate sheet if you need it. If you want a separate sheet, just let me know I can get your sheet. Who wants a separate sheet? Raise your hand. Okay. So, we need to. Where's your one? Anyone else sheets? Yes? No? Anyone else need sheets? No? Okay. So accuracy versus precision. I'm going to compare the two. Ooh, okay. Accuracy versus precision. So let's say we have a little metal cube. Yeah, I'm going to focus up here. It's important, okay. We got a little metal cube. The real mass, the actual true real mass is 1 gram. Okay? So let's say we know that. That's the given value, 1.00 grams. So we're going to write that. The real mass is 1 gram exactly, 1.00 grams. So let's say we're doing a lab, and we have to just get the mass of this cube, right? And we use a digital scale, but the digital scale is going to tell us 1 here. So the scale is going to tell us that it's 1.01 grams. Okay? Is that the correct mass? Is that the correct mass? What is the correct mass? 1.00 grams. Is it really close to it though?
Yes.
It's really close to it. So we're going to say, since it's very, very close, we're going to say this has a high degree of accuracy. It's very accurate. So this value of accuracy is very, very close. So let's say we use a different scale. So that's one group. One group measures 1.01. Another group has a different scale, and they measure it 3 times. This is the numbers they get. We're going to say they get 1.20, 1.19 grams, and maybe on the last one they get 1.21. Are any of these values correct?
No.
Are they close to the correct value compared to the other groups?
No.
Yeah, these are they closer to the correct value than this group's?
No.
No. But are they close to each other?
Yeah.
They're all very close to each other, so we're going to say that this, although they're not accurate, we're going to say they have a high degree of precision. So these all 3 are very precise. Precision. So to kind of put it into other words, we're going to say accuracy is when it's close to the real value, or the correct value. close to each other, regardless of accuracy. So just that they're closer to each other. Precision. Oh, yeah. Each other. So when you, now that, since we know the definitions of these, looking at precision, when the values are very close to each other, what's another name for that? Like if you're always getting this really, really close values, what can you say about how you're doing it? How would you describe that? Like when you repeat the same, or really, really close to the same number, that's very consistent. Okay, there's a lot of consistency here. So this is that's a key word here. We're going to say very consistent. Now, when you guys do your labs, like on Fridays, do you think that me and Mr. Medrano want to see you guys be more accurate or more precise? Like, we have to pick one. We can only pick one. Which one do you think is more important?
Accuracy.
Some say accuracy. Does anybody say precise? Why might it be precise? Or, first of all, why do you guys say accuracy? Someone tell me why would accuracy be important? Melissa. Why would it be important for us to be accurate in the lab?
Because you're closer to the right.
We want to get the right answer, right? Now on the flip side, what could be a reason that we want to be maybe precise?
Because you're getting something like
Consistent, yeah. Exactly, that word consistent, that's good. In the lab, actually, if we had to pick one, we're going to say precision is more important for us in the lab. Because of the consistency. Because I mean, if let's say we're getting these values like here, that may not be your fault, that might be the scale's fault. The scale might be a little off. Maybe the boat is throwing it off, like the weighing boat, or we forget to subtract the weighing boat or something like that. So, but these values are all very, very close. So that's actually, that shows that you're being consistent, you're doing it right. You know. Okay, so moving forward, we're gonna look at average real quick. Does everybody have this down? Can we leave it up front? We're good? Okay. Okay. So measurement average is just like the average that you learn in math class. You take the sum of everything divided by the number, that's your average. So we'll look at the numbers that we had with 1.20 grams, 1.19, and 1.21. What is the sum of all those? That is, let's see, 360. Divided by 3, since we got 3 there. 1.20. See 1.2? Right in the middle. It's the average, okay? So this is the same thing as that you guys have seen in your, you know, whatever math class you take. Percent error, that's just like it's just a formula, okay? So this is what it looks like. We have okay. So it's going to be a fraction. We're going to say we take the accepted value. We're going to subtract the experimental value, or the value that we measure. Experimental. Okay. Then we're going to divide that number by the accepted value again. And then you multiply by 100. That's what it is. Now let's say, going back to the mass again, we know the real mass is 1 gram. Okay? So let's say that we measured the 1.2, the 1.20. So let's calculate the percent error. What is the accepted value for the mass? Sorry?
What are you
accepted value, that's like the true value or the value that they give you.
1.
1. So for the mass example, it's 1 gram. We have 1 gram. And then what we measured? 1.20. I'm putting parentheses here because in your calculator you want to include those parentheses to get the right answer. So make sure you type those in. And then,
Divided by 1.
exactly, we're going to divide by the accepted value 1. And take all this, multiply by 100. So what's the number that you get from that when you punch it in? You can put it back in flow so you can give you a right answer. Yeah, negative 20%. That's right. Now, for this class, you can just put it, if it gives you negative or positive, you can put all your percent answers in positive, just as a positive, because it's just like the real, in college they'll ask you to just do the absolute value. So that makes everything automatically positive. But, so if you put negative, or you don't need to put the negative, is what I'm trying to say. You get full credit. But the negative though, the only thing that we care about is that, why would there be a negative here versus a positive? Why is this negative? Say it again, Anthony?
What if I'm wrong?
That's fine. Right.
Because the experimental value is greater.
Exactly, the experimental value is greater. So what would happen if the experimental value was less? Like, let's say it was 0.8.
It would be positive.
The value would be positive, exactly. So this negative, you're exactly right. All that's saying is that the experimental is bigger than the accepted. Okay? So that's all we want you to know. You don't have to include it in your answer though. If you don't put negative, that's fine. So now, let's go down to the next part. Now we want to talk about significant figures. Okay. Sig fig, here are the rules that you guys need to know. So let's go over these really quick. So all non-zero numbers are significant. All zeros between non-zero numbers are significant as well. Zeros to the right of the number and to the right of the decimal point are significant. Zeros to the left of the number are not significant. Zeros to the right of a number without a decimal point are not significant. And lastly, zeros in between a number and a decimal point are significant. Okay, so now you guys know significant figure, the rules. You can get started on your paper. Just ask me questions if you need help or anything. I'm just kidding, guys. So these rules are like, they're true, but they're not very good. They're kind of confusing. We have better rules that I'm going to show you right now. So, yeah, we simplified it into 4 rules. This is good for like all your sig figs. So we'll call it. Yeah, so you can write this right below it. We're going to call these, oh yeah, to abbreviate it for those of you who haven't heard it, it's significant figures, we call it sig figures. Right, like this is sig.
Big.
Yeah, sig figs. Yeah. So this is going to be, we're going to write 4 sig fig hacks. These are little hacks to help you guys, you know, it's just like a condensed version of the rules, okay? So the first one, any number that is not a 0 is significant. I don't care where it is. Any point in any digit that you see is not 0, that's significant. So let's write that down and say 1.
Other examples? Like weird.
Yeah. Yeah, we're just gonna write the secret hacks here. We're not gonna do an example yet. Any number that is not 0 is, and I'm just gonna write sig for abbreviation, is significant. Okay? So let's look at this number. We got 1.4 1.432. This number right here, 1.432. How many sig figs are in this one? Actually, sorry? 4, yeah. 4, exactly. So we have, how many of these are zeros?
Zero.
None of them. 0 or 0, exactly. Good point. So we got 1, that means we count them all. 2, 3, 4. This is 4 sig figs. 4 sig figs, okay? The next rule, we call this the bologna rule. Any rule, or no, any zero sandwich between non-zero numbers is significant, like a bologna sandwich, alright? So, bologna. Yeah, it's spelled really weird. I don't know where the pronunciation for bologna came from, but that's how it's spelled. So the bologna rule,
What does bologna mean though?
it's just a meat. I mean, whatever the bologna's made of. It's like
Oh.
you know, that's how you spell it. That's what I'm saying. It's weird. It's like
So you
spell like
put
bologna, but they say bologna. That's bologna. All right. Any zero sandwiched like a bologna. Between non-zero numbers is significant. Between non-zero numbers, let's split this, is significant. Okay, for example, let's look at 101. How many sig figs are there? 2, 3,
2.
2, 3. Well, let's look at, for sure, let's go back to rule 1. Any non-zero number is significant. So automatically, which 2 have to be significant?
1 and 1.
1 and 1. Alright. Yeah, 1 and 1. Okay. What about the 0?
It is because it's in between.
Yeah, it's sandwiched between 2 non-zeros, so that we're going to count it.
So that makes 3.
That makes 3.
Significant?
Yes.
Significant.
They're all 3 significant. Yeah. Let's do another example real quick. Let's look at 1, 0, 0. Wait for it. 0, 1. How many sig figs are there?
4, 5.
Let's see.
5.
Angelina.
5.
5, yes. Why 5?
Because they're sandwiched between 2.
Exactly. All the zeros are sandwiched between 2 non-zeros. You got 1, 2 pieces of bread, and then 1, 2, 3. Very, very good. Okay. Now let's look at another one. This one looks weird, or not weird, but it looks different, but it's the same rules. 1.001. This one, how many sig figs do we have? 4. Hector. How many sig figs? 4. Exactly. Why 4?
There's a sandwich between numbers.
Yep. Yeah, don't let the decimal throw you off. Decimal's just like an olive. If it's there, we just leave
Like
it.
a what's there?
It's like an olive. As long as it's a sandwich, you know.
It's a spoon.
Yeah. It's a 1, 2, 3, 4. Exactly. 4 sig figs. Still a sandwich. Okay. So the next rule, we call it the right rule. Okay? Let me explain this. Right.
That's 1 over 3?
Yeah, this is a third half. Right rule. And this is also talking about zeros. So if a 0 is right of a decimal and right of a non-zero, it's significant. But it has to be both. Has to be both. Has to be right of a 0, right of a number and right of a decimal. Let me show you guys what I'm talking about. So let's say we have 1.0. 1.0. How many sig figs are there? Let's say.
1.
Let's say. Brianna. 1 sig fig, 1 sig. Which one's sig? Which one's significant? 1 or 0?
0, right?
What about 1? Look at rule number 1. Any non-zero is significant.
Oh,
So You're saying 1 is significant. What about 0 though? Who said yes? Why is that one significant also?
Right, like that, right?
Yeah, that's both right. It's right of 1 and right of the decimal. So that one will also count. It's on the right. That's why. Now it's 2. It's 2 significant, okay? Let's look at another one. We're going to look at 1.000.
So this one, wait, sir, so this one is like,
How many-
every zero to the right is,
But it has to have both rights. It has to be right, meaning right of the decimal, and right of a non-zero number.
so,
On the first one, when it was a sig fig, because it was right of the number and the zero,
Yeah,
are all the
see.
zeros on this one gonna be?
It's right of the decimal and right of the number. See
Yeah,
that?
I know, but on the other one, are they all gonna be significant, or is only
Do
one
they
gonna be
follow?
significant?
If they follow this and all that, then yes, they are. So look at this zero. Is it right of the decimal?
Yeah.
Right of this? What about this one? Are you sure? Is it right of the decimal?
Yeah, but it's like,
Oh, wait.
right.
It doesn't have to be right next to the decimal, just as long as it's on the right.
what if there's no decimal and it's just 1 0? Or
That's
It's like, what if it's just like a
That's different.
decimal and then 0 0?
Just focus on this right now. So this
Okay,
one,
okay, sorry.
this one is it right of the decimal?
Yes.
Is it right of this one?
Yes.
Is this one on the right side of the decimal?
Yes.
Is it on the right side of the number?
Yes.
Yes, it is.
Is it number? It's on the right. So they're all. So how many of them are significant?
4.
4 of them. Yeah, they're all significant. So. Okay, just focus on this one for now. We'll clear up some of the weird stuff. This is 4. So now look at. Here we go. 0.0430. How many sig figs are there? 4? What is it? 4. So we know
5.
which one automatically 2 are sig figs?
4 and 3.
So 4 and 3, they're non-zero. So those are sig figs. Now what about this 0?
It can be.
What about this one?
No.
It's right at the decimal though.
Yeah, but it's not a number.
They're right. There's no number here. We can't count that. We can't count these 2. These 2, yes. What about that one?
No.
No, why not?
Because it's not sandwiched only.
There is a decimal though.
But it's not sandwich.
So what side of the decimal is this on? So on
That
the
is
right,
counted.
What side of the number is this on?
Oh wait, no, it's not counted because it's not on the right of the decimal, but it's the right of the number.
Okay, when I say right of the decimal, I just mean on the right side, not
Yeah.
right next to it, but just on the
Yeah, I
right
know,
side.
but-
It has to be on the right.
But it doesn't have a number
and
though.
decimal.
Yeah, and that order doesn't matter. The right and the right doesn't matter.
Oh, so it is counted.
It does count,
Oh my
yeah.
gosh.
It's on the right of a decimal, it's on the right of a number. So this on the right of a decimal, right of a number.
4.
The right doesn't matter, the order doesn't matter, and it doesn't have to be right by the decimal. That's a little caveat there. So that is 4, exactly. This is 4. 1, 2, 3, 4. Okay, so the last rule, call it period at the end rule. Period at the end rule. So have you seen a number, like when they put a decimal at the end, it kind of looks like a period, like this? Like 300, period. That period is actually a decimal. So anything, this is kind of like the sandwich rule, but with the decimal instead. So the zeros between this number and the period are significant. Okay, so how many significant figures are here in this one?
3.
3. Yeah. It's kind of similar to the sandwich rule a little bit. So we have 1, 2, 3.
So it's just a sandwich rule, but it doesn't have to be 2 numbers, it can be a number and a decimal.
Yeah, yeah, exactly. Yeah. So we have that. Now what about just 300?
No.
It just be 1.
1 sig fig only. There's no period. You know? So that's just 1. Like this is saying, for like a real life example of this, let's say they're rounding stuff or estimating stuff and they say like, oh, I have 300 exactly chickens. Put the dot. If you're like, oh, I have about 300, that's this. So it's close to 300, so it could be like 305, 310, 330. All of those round to 300, right? But we're not exactly sure. So that's like the difference between those two. So those are the 4 rules. Any kind of questions or anything? Right one's just a little tricky one. It doesn't have to be in a specific order, and as long as it's on the right side. It could be far away, but as long as it's on the right, you can.
So if like we come across any problem that doesn't go by these things that are not significant.
Exactly. And another big thing, you can combine rules. Like you don't, you can't say like you don't have to only look at one rule at a time. If it fits any or all of those, you're good. Or if it fits 2 or 3 or 4, you're good. You don't have to look at only one.
Why are significant figures?
Wait, one time with them.
Why are significant figures like reasonable?
This is just important for when you actually do like science stuff, like labs. It's when you're talking about like what you measure and like when you calculate stuff. It's just being consistent. That ties into like the precision stuff. It's like you'll see that more as you just go through the year. But just remember the rules for now. It'll make sense more as you go through stuff. So look at your sheet right now. I mean, what are you gonna say, Sergio?
This is like 303 period. This would be 366.
303.
With no period.
So just 303. Yeah.
Could be three.
Just the period tells you how sure they were with it. But that one follows which rule then? Yeah, just the sandwich. You can just look at the sandwich and say 3, zeros in the middle, 3 sigmas. So yeah. So look at your the back of your hand up, your worksheet. 2.3 assignment 1. I want you to do A through E. Just do A through E right now. I'll give you about 2 minutes.
A through E?
Yeah, A through E. A, B, C, D, E. 2 minutes.
We have to tell how many there is, or what's it?
Yeah, just count the sig figs. You don't have to write the rule. Just the number of sig figs. That's it. No need. None. You're first. Oh yeah. Okay, sure. Okay. Let's go through these real quick. The first one, how many sig figs are there?
4.
4. So we have, you don't have to write the rule, but this is the sandwich rule. 1, 2, 3, 4. Here, same rule applies even though it has the little dot. How many sig figs?
5.
5. Yeah, 1, 2, 3, 4, 5. That's too small. Okay, what about this one?
4.
4. Why is it not 5?
Because it's not number is
Yes. That one was.
C.
Yeah. Does that 0? Does this 0 follow the right rule?
No.
It's all the way to the left. That's not good. Okay. D.
3.
3.
Because it's to the left and to the right of the decimal and then
What rule does this follow? Right, yeah. Triple R actually. R rule.
Triple R.
Triple R. R cubes. Okay. This one, how many?
6.
Yeah, what about these two? What about these two?
There's no number after the decimal.
They're right to the decimal. Is that right? No.
Wrong.
That's not right, even though they're right. It doesn't follow the triple R. So this, only these guys. Why are these zeros counted? Sandwich, very good. It's the bologna rule. Okay. That's 6. Alright, awesome. Great.
So does it follow the right rule?
Which one? E?
Yeah, didn't you say
Yeah,
that?
these do. These follow it, and they also follow bologna. See, that's what I'm saying. Like, you could look at more than one rule. If it counts for both, that's okay. It doesn't have to follow only one. That's like impossible in a lot of cases. But so yeah, those are those problems. Now flip it to the other side. All right, let's look at the first problem, number 1. Okay. Density, okay. Number 1, the density of a substance is 3.71 grams per milliliter. And they say, when you see is like that, that is the accepted value. Alright? Keyword right here, is. That's the accepted value. No triangle necessary in this one, actually. This is just percent. Yeah. But the second statement, if you found the density of the substance to be 4.12, what's a percent error? If you did it, like in a lab, that means that's experimental. Yeah. Another key word there. You got you.
You found.
That's experimental. Okay. We're gonna do this. Let's see. Percent error. Get your accepted value. That's experimental. Accepted. Remember, put this in the parentheses on the top. Times 100. So let's see, the one they give you, 3.71. This one that you got, 4.12. All over 3.71. What does this come out to?
11.3.
11. Negative 11?
Yeah.
Okay. I'll just put positive 11. This is just percentage. Round it to 1. Why is it a negative?
Because it's bigger than.
Why is it negative? Jane. What's the thing negative?
It's
Yeah, this comes out as negative 11.
Because the experiment is greater than
Whoa. Sorry? Yes, exactly. The experimental value is greater. This value is bigger than that, so 3 minus 4, is that going to be positive or negative? Negative, right? Oh, okay, so that's what I wanted you guys to see there. But you can put it positive on your quiz or whatever, that's fine. What are the units we put here?
If we were to put a negative, would it be wrong?
ML.
It's not even kind of wrong, it's just it's not, you don't have to put it. Sorry?
GML.
Actually, percentages, they have no units. I just
You
want
asked me
you
that, sir.
guys to- All you just put is percentage, okay? So
And I was
now,
like, does it go before the percent or after?
yeah, the units just cancel, always with percentage.
So we don't have to put the negative sign.
No, you don't have to put negative. We're just seeing how far away it is from the real value, percentage. Okay, so what I want you guys to do is just do the rest of this right now for the rest of the class. This is due tomorrow. If you're done with it, just hold on to it now, okay? And if you finish before the class ends, you can come to me, I'll check your answers. You know what you're doing. Okay, yeah.
So we just have to put
Okay,
like
right, you can go
the
get a
number, right?
Were you gonna go to trainer or to the turn?
We can just go, we don't have to put like what rule, right?
Yeah. You don't have to put the rule. This side you don't have to put the rule, just the number. This side, show your work. You know? Alright, if you have questions, ask me. If you want to check your work, ask me too.
All right.
It's next to the one with the relative.
Yeah, so look at this one. I'm not going to touch it, but I'm just going to put these two. Look at where they're between 1 and 5. Yeah, you can look at that way. That's right too. Also, these two. Look at the all the right letter 1. But I guess. Are they? Which one's just? Yeah.
I'm gonna walk you to the nurse, and then I'm gonna go sign that second period.
Okay. All right. Yes, exactly. Why would the first one? They follow the right. You're right. Hold on to it for tomorrow.
Sir.
If you're done, just hold on to it. Yes, you hold on to it. It's okay, yeah. Yeah, those are cool. Yeah, there's no Yep. Which one?
No, I.
Which one? HR. Okay. These two are different because of the period. So when it's a period, so like the period rule, it's like the same tool, it's just one was a period. So this one, you all sandwich like a number in the period. So yeah. But here, there's not the period because of the other end of the sandwich. So you can't count those ones. Yeah. You did it. Right, you estimated. Yeah, it should be the same. It happens to be, yeah. Number 4 should say it, just in case any of you guys saw that. It happens. Slowly. You don't have to put it next time.
Sir, if one of our answers happens to be 0.9, do we just round it?
0.9%.
Yeah. Or let's put like 33.9%. Or we put 34.
What's the number? You can put 34.
34? Okay, thank you.
Hold on to your. Are you guys in? Oh, take it, yeah. Your setups look good. I say just go back and double check. Punch them into the calculator one more time and make sure the number is right. So your setups are right. Okay, that's good. Yeah. Good. Yeah, all the setups are good. Is up? Sure.
Can you check mine?
Here, let me show you this one here. So, what would be your trigger value? Yeah, what it is, yeah. That minus what?
No, never mind.
Yep. So that number divided by what? Remember, you want to draw a line, it's that divided by that. Go ahead and draw a line. So now, this is the number you said, right? Minus whatever it's over that 7. Good. Good.
I got you.
Okay. Yes, So if you're done, just hold on to it. We'll grade it tomorrow. First thing. You guys are really good. You guys remember that form I gave you?
The what?
Remember last week I gave you the form?
Oh yeah, we didn't have your video.
No one signed it, right? Nobody? It's awesome. There was a hidden camera today.
What?
The hidden camera. Can you see it?
There really? It was like
Yeah.
that.
Good. You guys didn't notice.
Where is
You didn't
it?
notice. It's right there.
What? Actually, I signed the paper. No, I'm kidding.
Oh, yeah. I'll edit you out.
Dad.
If you cheated on anything, I'll see it. It's on camera forever. So I busted you.
Wow.
Alright.
You got it, sir.
You're gonna see me come on.
See what? So what?
Let's talk about the pens.
Part of the.
He noticed.
So, when do you want the donuts?
Friday.
Can't do it on Friday.
Yeah,
We're doing Thursday.
Tomorrow.
Wednesday. Wait, so I'm not gonna be here.
Yeah, maybe not.
How about on a Wednesday? I think everybody should, there's nothing on Wednesdays going on.
So tomorrow? Tomorrow's
On
Wednesday.
Alright. So it'll be on a Wednesday. I'll give you plenty of warning so you can be absent. You can add eat more than one donut. They already warned us today how bad it was to give you guys food. That some people have been giving people food. Or no, some of you know what those classes where you always have parties in?
Oh.
Yeah, you
Who
know.
has parties in high
Oh
school?
my gosh, I was seeing you with walking with sodas in case you guys don't even try
Okay,
to hide it, man.
I wish I had those classes.
I had that class last year.
I would never have those classes.
Yes, we did.
I never had them. That one time, the year before that, they made cookies, remember?
Yeah, she's super like do it in 30 minutes.
That's it. No, other classes would have parties like every Friday.
We figured it out for that.
Like 2 or 3 years. The coach for the girl.
Like, she was super nice.